Good evening. Tonight we're going to be looking back at some of our scatter plots that we've done, and we're going to tie in some of our vocabulary that is just oh so important. The first thing I want you to notice is that I have written distance and intersections right here. Down here for the x-axis we wrote distance, and up the side we had the number of intersections. That makes our domain go with our x, which would be the distance, and our range is going to be the intersections. Now, I'm going to give you some time, you can pause the video, to go into your notes and to plot the same graph you had before. It can be a sketch, doesn't have to be perfect. Go ahead and pause now and plot it, and we'll come back in just a moment. Welcome back. Now that you're looking at your data, I don't have any data on my chart, you need to decide if it is a function or just a relation. Remember that a relation is just points plotted on a scatter plot. That is exactly what we have in distances and intersections. We have a relation. There is no mathematical pattern, so it stays a relation. Is the data discrete or continuous? Because they are just points, the data must be discrete. We should not connect it. I know there is a trend line, and we talked about drawing said trend line, but we are not going to connect our points. This is not a line graph. Here for domain, I want you to list your points that you graphed, because the domain will be the x, and the range will be the y. Moving on to our next bit of data that we looked at, we used bug legs. Fun stuff. We had the number of legs here, and we had the number of bugs down below. This graph I can do with you because all of our graphs looked exactly the same. Alrighty, now let's decide if this is a function or a relation. Because there was a mathematical pattern, that does in fact make this a function. We have to look at if it is discrete or continuous. In this case, it is discrete again, because I know what you're going to say. You can have part of a bug and you can have part of a leg, but in math, you really can't. We're going to stick with that you are going to have full bugs and full legs attached. The domain is going to be your bugs, and the range is going to be here on your y, the number of legs. Again, these are going to be the points you plotted. So for this one, we're going to have our little, oh, that was a really bad bracket. We're going to have our number of bugs, which was 1, 2, 3, 4, running out of room, 5, a really bad bracket. And our range is going to be the y's that go with them. In this case, 6, 12, 18, 24, 30. Terrible brackets there. Now we're going to look at burning calories. Burning calories is a graph that you will have differently. However, I believe that we all graph them the same way. Where this was, excuse me. Let's look at the function and the relation part. My question for you is this a mathematical pattern? If you say yes, then you need to put function. If you say no, you're going to put a relation. If there was a mathematical pattern that helped you figure this out, then you will put, what again? Function. If there wasn't, then it's just a relation. This is the first time our graph is continuous, and you should be connecting the points. I spelled that wrong. Got to have a U in there. Good stuff. It is continuous because our graph is going to be connected. Why? Because in this case, you can have part kilocalories and part time. The domain, what is the lowest value for our x's? You're going to write that here. And you'll write x is greater than or equal to that amount. The same is true for your y, where you're writing y is greater than or equal to that amount. I'll give you a hint. Has something to do with the origin. All right, now you're going to take some time. You're going to listen to some situations and fill out the dependent and independent variables. A very large animal will eat many pounds of food. Situation 1 says, a very large animal will eat many pounds of food. Situation 2 says, the temperature of water on the heated stove rose each minute. Situation 2 says, the temperature of the water on the heated stove rose each minute. Now for situation 3, you can see that I have already written the situation down. I want you to figure out the dependent and the independent variables, and then I want you to solve for where x is 2 and for where x is 6. F of 2 and f of 6, meaning you're going to plug in and solve for both the number 2 and the number 6. Have a great night.